Welcome, dear listener, to the Sleepy Atom. Tonight we drift into one of the most quietly powerful forces in existence, gravity. It does not shout, it does not flash, it does not demand attention, and yet it holds galaxies together, bends light itself, and sculpts the paths of stars, planets, and even time. Without gravity, there would be no planets to walk on, no moons to dream under, no you. So let us relax into its silence, gently, slowly, as if we are falling into the curve of space itself. Because gravity isn't just a pull, it's the shape of everything. The gentle tug beneath everything. If you let a feather go in space, it won't fall. At least, not like it would on Earth. But that doesn't mean gravity disappears. In truth, it never leaves. It just moves quieter, slower, woven into the background like a hidden hand. Gravity isn't some loud magnet, it's more like a quiet agreement between mass and space. Wherever there is mass, there is a tug. Not a push, not a pull in the usual sense, but a kind of bending. That's where we begin, in the space between things, where the story of structure begins to fold quietly. From the moment the universe expanded outward, a soft breath after the Big Bang, gravity stepped in. It didn't crash anything together right away. No, it waited, patiently. It allowed clouds of gas to drift, form, swirl. Then, almost like an invisible artist, it began guiding them into shape. Stars were born not in explosions but in compression, slowly, reluctantly, over time, and it was gravity that kept them alight, crushing their cores until they ignited. All that brightness we see up there? It's because gravity leaned in and whispered, "Come closer." Even now, every time you drop a pebble, sip tea, or watch the moon rise, you're participating in a quiet cosmic ritual. You're watching gravity at work. And though it feels simple, a thing always falls down, it's not. What we call down is really toward the center of a planet that itself is locked in a soft fall around the sun, which is itself falling softly through the arms of the Milky Way. And that galaxy, it's falling too. No one is still. Everything is leaning, forever. So why does it all feel so quiet? Why doesn't gravity make a sound? That's the beauty of it. Gravity doesn't need to shout. It's not a force of chaos, it's a force of shape. It tells planets how to orbit, tells light how to bend, tells time where to slow. It governs with a whisper. Like a riverbed that silently carves the path for water, gravity doesn't force. It allows. That's why we often forget it's even there. Until something falls, and when something does fall, a star collapsing, a black hole forming, an apple dropping, we're reminded. Oh yes, something unseen is always working, always curving space beneath our feet, always pulling softly without sound. Ahead we drift deeper into this silent sculptor, and how it doesn't just move objects, it shapes existence. Space isn't empty, it's bent. Close your eyes and imagine space. Most people picture a flat black sheet, infinite, quiet, and empty. But space isn't flat, and it's not empty. Not really. It bends. Not just near stars or planets, but everywhere mass dares to exist. Gravity isn't a thing that acts on space from outside. It is space, a curve, a warping, and that bend shapes the path of everything that passes near it, from dust to light to time itself. The more mass something has, the deeper the dip it creates, like a child sitting on a soft bed, shaping the mattress around them. Einstein was the first to describe this, not as a force pulling, but as a geometry changing. He called it space-time. 4 dimensions woven into one soft fabric. Place a star in it, and space curves around it. Place a planet nearby, and the planet moves not because it's pulled, but because it's simply following the curve. It's like rolling a marble around a funnel. It's not being pulled, it's obeying the shape. The shape is gravity. Now imagine light passing near that star. You'd think it would go straight, but it doesn't. Light bends too, not because it has mass, but because it can't resist the shape. This bending, called gravitational lensing, lets us see galaxies behind galaxies, curved into halos like cosmic echoes. Space is sculpted, stretched, layered. Not emptiness, but architecture. And time? Time bends too. The deeper into gravity you go, the slower time ticks. Atomic clocks on mountaintops tick faster than those at sea level. GPS satellites must adjust for this every day. The flow of time is not fixed. It ripples. It stretches. It depends on where you stand. That means gravity doesn't just shape the where of things, it shapes the when. It shapes the story, the sequence, the rhythm. So when we say gravity shapes the universe, we mean all of it. Where planets go, how stars form, when events happen, even how long something feels. It sculpts the choreography of reality, gently, silently, without ever needing to be seen. The dance of moons and tides. If you've ever stood near the ocean, you've seen gravity at play, not in the crashing waves, but in the gentle breathing of the tide. The moon pulls at Earth's oceans, and Earth pulls back. This delicate stretching causes the water to bulge, not once but twice, on the side facing the moon and the side opposite. And this isn't just a surface effect, it's gravity's whisper moving entire oceans. But it's not just the oceans that move. The Earth responds too, ever so slightly. The ground beneath your feet rises and falls each day by tiny amounts, a quiet reminder that gravity is more than a force. It's a relationship. Earth and moon are dancing, caught in each other's soft gravity wells. And that dance affects life. Migration, sleep, coral spawning, all timed to the moon's soft tug. Even the moon itself is shaped by gravity. It always shows us the same face, not by chance, but because gravity has locked its rotation to its orbit. This is called tidal locking. It's not an accident. It's the end result of millions of years of soft pulling, balancing, and settling. What we call synchrony is just gravity finding peace. Further out, moons tug at planets, and planets tug at moons. Jupiter's moon, Io, is squeezed and stretched by Jupiter's enormous gravity, causing volcanic eruptions to burst from its icy crust. Saturn's rings ripple and shimmer because of moonlets inside them, carving patterns in the dust. Every orbit is a conversation, a rhythm, a curve pressed into the sky. So when we look up and see the moon, or watch the tides roll in, we're seeing gravity in action, not crashing, not exploding, just shaping, stretching, aligning. The music of orbits is silent, but it never stops playing. Galaxies are spiral sculptures. When you look at a galaxy from far away, a soft swirl of stars, dust, and gas, you might wonder, why the spiral? Why this shape? The answer lies in motion and in gravity's long patience. Every star in a galaxy is orbiting, not in a perfect circle, not all at the same speed, but in a kind of cosmic swirl. This uneven motion, guided by gravity, creates spiral arms, patterns that emerge not by design, but by flow. Gravity doesn't just clump matter, it stretches it into forms. Over time, stars that form in certain regions bunch up as they move, like cars in traffic on a curve. This forms bright arcs. The arms are not fixed objects, they're regions of density, places where stars are born more often, like glowing waves in a turning sea. Gravity arranges not just placement, but tempo. And it's not just stars. Clouds of gas move through this spiral too. When they pass into the denser arms, they compress. And out of that compression, new stars are born. So the spiral isn't just a shape, it's a nursery, a cradle of heat and light sculpted by gravity's invisible fingers. Our own galaxy, the Milky Way, is one such spiral, and inside its arms our sun drifts slowly, taking 225 million years to make one full lap around the galactic center. It's not locked, it's not straight, it's curved, wrapped, carried. Gravity doesn't rush, it glides. And so, the shape of galaxies tells us a story, not of chaos but of choreography, of millions of stars obeying one gentle law and forming something quietly beautiful, falling, without ever hitting the ground. Here's something strange to consider. The moon is always falling. So is the Earth. So is the International Space Station. But they never land. Why? Because gravity allows a special kind of falling, one that curves forever. We call it orbit. But really, it's a fall that keeps missing the ground. And that idea alone reshapes everything we think we know about motion. Isaac Newton was the first to imagine this. He said, if you fire a cannon fast enough, it would fall around the Earth rather than into it. That's an orbit. Not escape, but surrender. Gravity doesn't trap it, it carries it. Softly, like a ball rolling inside a bowl that never ends. Astronauts feel weightless in space not because there's no gravity, but because they're falling with it. The station is falling. They are too. No push, no force upward, just surrender to the curve. And in that surrender is peace. No pressure, no strain, just glide. Planets orbit stars the same way, not with rockets, but with permission. Gravity invites them into curves, and they accept. This acceptance makes stability, seasons, cycles, life, all because nothing resists the fall. It leans into it. So when we say gravity holds everything together, we don't mean it grabs and clenches. We mean it allows a path so elegant, so curved, that nothing ever hits the ground. It just keeps falling, forever. The invisible architect of orbits. In the grand silence of space, planets trace perfect loops around stars, not because they choose to, but because gravity whispers the path. There's no hand guiding them, no trail of crumbs to follow, only a constant invisible pull. Gravity doesn't shout, it murmurs softly across distance. What looks like a planet freely gliding is really a constant falling, forever missing its star. That's what an orbit is, missing the thing you're falling toward over and over again. You see it when you toss a pebble. It arcs, curves, and comes back down. But throw it faster, from higher, and it falls around the Earth instead of into it. This is what satellites do. This is what our moon does. This is what every planet has mastered, falling without ever arriving. Gravity doesn't force this into existence. It simply bends the stage enough that anything moving straight will curve. Even light, which should always go straight, bows to this subtle warping. Like a silk sheet stretched too tight, dipped gently by a marble resting in the middle. And the stranger thing is, everything responds to this bending, even time. Around massive planets or near black holes, time itself moves slower. We've put atomic clocks on jets and flown them around the world, and they tick differently than those on the ground. It's not science fiction, it's GPS. Your phone's maps would be wrong if not corrected for gravity's tug on time. That's how deep this silent pull runs. It reaches into the fabric of now and tugs, just enough to shift the ticking of a second hand. We don't often think of orbits as poetry, but they are. The Earth isn't trapped by the sun, it's dancing with it, circling, waltzing, never colliding. It's a soft chase with no finish line. And this same waltz plays out on moons, on asteroids, even on rings of Saturn that look still but are really countless icy pebbles, each following their own path, each caught in their own fall. That's the elegance of gravity, simple, quiet, and endlessly repetitive. So when we look up and wonder why everything doesn't just drift away into space, the answer is because space itself isn't still. Gravity has bent it, warped it, turned it into a gentle slide, and everything that moves slides along, not because it must, but because that's how gravity shapes the rules of motion, with no need for sound or colour, only a curve in the quiet. The secret conversation between galaxies. In the vast darkness between galaxies, gravity still speaks. It's not loud, but it's persistent. Entire galaxies, spiraling, ancient, glowing, pull on one another across millions of light years. They're not colliding randomly, they're falling, curving, orbiting on cosmic scales. Every flicker of starlight we see from a distant spiral tells the same story. A push, a pull, and a patience that only gravity can sustain. These galaxies aren't lonely. They live in clusters, sometimes tangled like dancers holding hands. And when they do finally collide, because gravity never gives up, they don't explode in chaos. Instead, they blend slowly. Stars weave past each other. Dust compresses into new birthplaces for stars. Two giants becoming one, not in violence, but in time's soft embrace. It can take 1 billion years, but gravity doesn't mind waiting. What's breathtaking is how gravity decides the future of these galaxies long before they even meet. Their shapes, their motions, the stars they'll form, all of it is influenced by invisible threads pulled tight across the universe. We call it dark matter because we can't see it, but it's there, adding just enough mass to steer the course of cosmic destinies. Without it, galaxies would fall apart. With it, they form elegant spirals that turn in near-perfect rhythm. So the next time you see a photo of Andromeda, our neighbouring galaxy, remember, it's already in slow-motion flight toward us. In 4 billion years it will arrive, not with fire, but with fusion. Our galaxy and hers, merging in silence, guided only by a gravity that's too gentle to feel, but too strong to escape. And that's the magic. Galaxies don't just float. They listen, they curve, they fall. And in that falling, gravity writes a cosmic poem that spans more than space. It touches time itself. When light loses its straight line. We like to think of light as the fastest thing in the universe, and it is. But even light isn't free. Gravity, quiet and invisible, can bend it. Not by pushing, not by blocking, but by curving the very road it travels on. This bending has a name, gravitational lensing. It's one of the most elegant tricks the universe performs, and we can see it even from here. Imagine looking at a distant star, one far behind a massive galaxy. That galaxy's gravity warps space so strongly that the light from the star bends around it, reaching us from different angles. When it happens just right, we don't see the star at all. We see a ring of light or a duplicated glow like a cosmic mirage. Einstein predicted this. Telescopes proved it. The lens is not a glass, it's gravity. Gravitational lensing lets us see things we never could otherwise. Galaxies that should be hidden, light from the early universe, even planets around stars we can't directly observe. It's like the universe lent us a magnifying glass, but instead of a handle, it's made of curved space, wrapped around silent mass. This bending also shows us something haunting, that space is not flat. It's shaped, sculpted, alive in motion, and every beam of light remembers the shape it passed through. That's why we can map dark matter. We can't see it directly, but we see what it does to light. Gravity reveals itself not by being visible, but by how it changes what we thought we understood. And just like that, something we thought was simple, a beam of light, becomes a storyteller, a traveller, a message from across time bent softly by a gravity it never resisted, just gently followed. Gravity's soft grip on time. We tend to think of time as a constant, tick, 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 but gravity knows better. The closer you are to something massive, the slower time moves for you, not metaphorically, literally. Time passes differently depending on where you are, and gravity is the reason. It's not a glitch. It's the geometry of the cosmos. Astronauts orbiting Earth age just a little slower than we do. Clocks flown high above the ground don't agree with those on your desk. The difference is tiny, but real. It's not science fiction. It's how your phone's GPS stays accurate. If satellites didn't correct for gravity's time shift, your directions would be off by kilometers. And the deeper the gravity, the stranger it gets. Near a black hole, time stretches so far that a few minutes close to it could mean years far away. It's not magic. It's the curve of space-time pulled tight by mass. Every second we live is shaped, very slightly, by where we are and what we're falling toward. This means that gravity doesn't just hold us to Earth, it holds us to now, to when, to how long. Your heartbeat, your dreams, your memories, they all happen in a time that is not quite the same as anyone else's. And gravity, silently, is the reason for that gentle difference. In the quiet of space, time doesn't tick the same way twice. It stretches, it relaxes, it breathes. And gravity is its lungs, the stillness that holds everything moving. It's strange, isn't it, that something we never feel controls everything. Gravity isn't like wind or heat. It doesn't shout. It doesn't sparkle. But it's everywhere, constant, patient, shaping every move the universe makes. From your feet pressing into the floor to galaxies swirling in the dark, it's all part of the same quiet grip. The universe expands, stars explode, planets spin, all while wrapped in gravity's hush. Even in stillness, even in sleep, the pull never fades. Gravity doesn't get tired. It doesn't take sides. It simply curves the canvas and lets everything else follow the shape. And the wildest part? We've never actually seen gravity. We only see its results. We drop a ball. We stay grounded. We see moons orbit. But the cause? It's invisible, unmeasured by sight, trusted like breath. Even our atoms respond to it, not by decision but by nature. It's part of the instruction manual that built this place. So when you lie down and feel nothing but the quiet of night, know that gravity is still there, whispering structure into the silence. You don't have to hear it to belong to it. You already do. And ahead in this video, we'll explore even stranger ways gravity shapes not just motion, but the shape of time itself. The quiet grip, holding galaxies together. Galaxies from afar seem like beautiful swirling islands of light, but what holds them together in such orderly spirals, spinning but not flying apart? The answer is gravity, though not in the loud, dramatic way we might expect. Gravity in galaxies doesn't announce itself. It doesn't push or shove. It simply holds, slowly, steadily, almost like the memory of something that once whispered, "Stay here." Scientists have watched galaxies spin in ways that suggest something more is there, an unseen companion holding things tightly, yet silently. You see, stars on the outer edges of galaxies orbit far faster than they should. If only the visible matter were responsible, those stars would have flung off into deep space long ago. But they haven't. They hold their place, as if bound by invisible threads. This odd behavior was one of the first clues that something else, something dark and silent, must be shaping the galaxy's dance. A quiet mass we can't see, but we feel its tug. that something is what we now call dark matter. It doesn't shine, it doesn't speak, but it makes up most of the matter in the universe. Without it, galaxies wouldn't form the way they do. Their elegant arms would unravel, their centers would drift. Gravity, especially the silent, hidden kind, is what choreographs this cosmic waltz. Every star, every orbit, every spiral arm, in rhythm with an unseen conductor. And yet, we've never touched dark matter. We've never held it, never seen it with our eyes. We only know it exists because of how it pulls. The way a handprint might linger in soft dough, gravity leaves its impression. Dark matter doesn't need to be loud to be powerful. In fact, it's precisely its silence that makes it so hauntingly persuasive. Ahead, as we drift into even larger structures, clusters of galaxies, superclusters, we'll find that gravity doesn't stop at stars. It binds things across distances too vast to imagine. Galactic highways made of gravity. Clusters of galaxies are not isolated islands, they're neighborhoods. And those neighborhoods are connected by roads, not made of asphalt, but of gravity. Scientists call this the cosmic web, a great sprawling structure of dark matter and galaxies like glowing beads on invisible strings. It stretches across the observable universe, forming the largest structure we've ever detected. And yet, you can't hear it, you can't see it, but it's there, tugging gently on everything. Imagine being inside a spider web that spans the cosmos. Gravity is the thread. Galaxies are the dew droplets clinging to the lines. Each thread connects to another, forming filaments and nodes. These threads don't light up on their own, but galaxies cling to them, drawn into their embrace. It's through these cosmic connections that matter flows, from emptier regions into dense clusters. A quiet migration guided by gravity's hand. This web was shaped in the early universe, when everything was still settling down from the Big Bang. Tiny ripples in the distribution of matter became rivers. Rivers became roads. Roads became gravity wells, and galaxies followed their curves like leaves in a gentle stream. What's incredible is that gravity doesn't need to be strong to do this. Over billions of years, even the faintest nudge becomes a pathway. Scientists have captured glimpses of this web using light from faraway quasars. As that ancient light travels, it weaves through this network of dark matter and gas, revealing shadows and patterns, like dust caught in a sunbeam. It's delicate, barely noticeable, and yet it holds the entire architecture of the cosmos together. The galaxies are just the lights. Gravity is the scaffolding behind it all. In the chapters ahead, we'll slow down even more and observe how gravity sculpts not just space, but time itself. The slow warping of time near massive things. Time isn't constant, it bends, and gravity is the sculptor. The more massive an object, the more it slows down time around it. This is not science fiction, it's one of the strangest and most beautiful consequences of Einstein's theory of general relativity. Near a planet, a star, or especially a black hole, time actually ticks slower than it does in emptier space. It's as if the clock sighs and relaxes under the weight of gravity. This means that astronauts aboard the International Space Station age slightly slower than we do on Earth. That GPS satellites, which orbit above us, have to account for time flowing differently than it does down here. It's not a glitch. It's how the universe works. Gravity doesn't just pull objects, it gently stretches time like warm taffy, slower in its grasp, quicker when free. The heavier the object, the stronger the effect. Near a white dwarf or neutron star, time slows more noticeably. Near a black hole, it becomes almost poetic. If you were to hover just above the event horizon of a black hole, carefully balanced, time would move dramatically slower for you than for your friend waiting back home. Years could pass for them. while minutes tick for you. A farewell hug becomes a lifetime. This distortion isn't just theory. We've measured it with atomic clocks, incredibly precise machines that lose less than a second in millions of years. Set one on a mountain and another in the valley, and they'll disagree. Gravity has a quiet say in how time flows. It's a whisper, not a command, but it changes everything. And as we drift further into the cosmos, we'll begin to feel this stretching of time in ways that go beyond clocks into light itself. Light loses its color to gravity. Light, despite being fast, isn't immune to gravity's pull. When it climbs out of a gravitational well, like from the surface of a star, it actually loses a bit of energy. And because color is linked to energy, the light subtly shifts, becoming redder. Scientists call this gravitational redshift. It's a small effect near Earth, but near stronger gravity, the shift becomes profound and beautiful. Imagine sending a pure beam of blue light from a planet's surface into space. By the time it reaches an observatory far above, it's ever so slightly less blue. It's not because anything touched it, but because it had to fight its way out of gravity's soft grasp. Like a bird flying uphill, it loses just a touch of color in the climb. This redshifting is one of the quiet fingerprints of gravity. It tells us how deep a well we're looking into. It helps us measure the pull of distant stars and planets, even black holes, whose light is shifted so extremely that much of it becomes invisible to us. And yet, it tells a story. A slowing, a fading, a surrender to the curve of space. What's truly poetic is that this isn't just happening in one place. It happens across the universe, in every direction. Every photon climbing out of every star, arriving at your eye or a telescope's lens, has carried its journey across both time and gravity. The light we see is always slightly tired, but still glowing. Coming next, we'll pause at the largest stage of all, where gravity, time, and silence wrap around the expanding edge of the cosmos itself. The expanding universe feels empty, but isn't. At first glance, the expanding universe might seem like a quiet outward balloon, galaxies drifting farther apart, stars growing more distant, and space itself stretching between them. But this expansion is not just motion, it's time in motion. The farther away a galaxy is, the faster it seems to recede from us. And with that distance, its light stretches too, echoing the same redshift we just spoke of, only this time on a cosmic scale. This is known as cosmological redshift, and it tells us something profound. That the universe isn't expanding into something, it's creating space itself as it grows. Gravity, instead of pulling everything inward, has been letting go, or at least giving way to something stranger, dark energy, a force so subtle we barely understand it, and yet so powerful it's accelerating the expansion. Even in silence, the cosmos speaks through motion, but the illusion here is that these galaxies are flying through space. They're not. Space itself is expanding between them, like dots on an inflating balloon. It's not the dots moving, but the surface growing. And gravity, it's trying to hold it all together, but only to a point. So as we gaze farther into the night, what we're really seeing is a conversation between gravity and expansion, between attraction and distance, between the old universe and the new. The space between things is growing, but gravity never entirely lets go. And beyond all of this, the cosmic microwave background, a soft ancient glow, waits like a whisper from the moment everything began. As we keep drifting, we'll soon arrive there too, the gravity between galaxies. There's a silence between galaxies that feels almost too still, as if nothing could ever disturb the dark. But gravity is not bound by distance. It stretches between galaxies like a forgotten thread, invisible yet strong. These gravitational bridges pull entire star systems toward each other, slowly, patiently. What looks like nothing is a quiet tug of war older than language. In the deep intergalactic void, matter isn't evenly spread. Some galaxies seem drawn toward empty patches of space, while others cluster like glowing cities on a dark landscape. That's gravity once again, carving a path without ever saying a word. Scientists call this large-scale structure the cosmic web, a name that fits. You can't see the thread, but the shape is there. This cosmic web wasn't planned. It emerged. Small gravitational fluctuations in the early universe pulled matter toward themselves, and those ripples became strands, walls, and filaments over billions of years. What began as whispers in the quantum foam ended up shaping everything we see through telescopes today. And in the middle of those threads, galaxies, stars, us. Even when galaxies seem isolated, they are still part of the dance. Every motion they make is guided by gravity, not just their own, but the pull of unseen neighbours far away. Some move in groups, others fall toward massive clusters, and all of it happens in the dark, with no fanfare, just quiet motion over unimaginable spans of time. So when you see images of galaxies drifting in the black, remember, they're not floating freely. They are moving along invisible tracks written by gravity long ago. We may never hear it speak, but in silence, it choreographs the cosmos, collisions that build the universe. Galaxies don't just drift, sometimes they collide, but unlike the crashing sounds we know on Earth, these cosmic collisions are eerily silent. No noise, no sparks, just stars weaving through stars as the galaxies merge into one. And yet it changes everything. When two galaxies collide, they don't explode. They dance. Their stars pass each other like ghosts, too far apart to touch directly, but gravity changes their orbits, slingshots them, reshapes their paths. Gas clouds crash, triggering new waves of starbirth. Entire regions light up. It's like the universe taking a deep breath and creating again. The Milky Way, where we live, isn't immune. In about 4 billion years, it will merge with our neighbour, the Andromeda Galaxy. The two will become one. Not with destruction, but with transformation. It's a reminder. Gravity doesn't always pull things apart. Sometimes it brings them together into something new. These galactic collisions are not rare. In fact, they're one of the main engines of cosmic evolution. Most large galaxies, including ours, are the product of countless mergers. Quiet unions that build beauty from chaos, all under gravity's calm guidance. So when we look out and see two galaxies entwined, we're not watching an accident. We're watching creation, unfolding in slow motion, guided by a force that never rushes, never rests, and never leaves behind a sound. Gravity and the sculpting of spiral arms. You've seen them, those swirling galaxies with spiral arms like pinwheels in space. They seem frozen in a moment of motion, but they are shaped by something invisible. Gravity, once again, drawing patterns in the stars. Spiral arms are not like solid structures. They're more like traffic jams in space, places where stars, gas, and dust pile up temporarily as they orbit the galactic center. Gravity creates these density waves, like ripples in a river, slow and steady. Stars pass through them, like dancers moving through the rhythm of a song they can't hear. As gas clouds enter these denser zones, they get squeezed, and new stars begin to form. So spiral arms aren't just decorations, they're star-making factories, nurseries carved by gravity's quiet persuasion. Even after billions of years, the spiral pattern holds, a slow, never-ending turn in the dark. What's beautiful is how these arms can persist even when galaxies collide or shift. Gravity adapts. It doesn't resist change, It guides it. Sometimes the arms twist tighter, other times they blur into new forms, but they always return, not in the same place, but with the same motion. So when you look at a spiral galaxy, know this: you're looking at a story, one written by gravity's hand, a story that's still unfolding, silently, endlessly, and without a single spoken word. Black holes and the center of every galaxy. At the heart of most galaxies lies something hidden, not a star, not a planet, but a black hole. And not just any black hole, a supermassive one, millions or billions of times the mass of our sun. Yet, it makes no sound. Its power is in its silence. These black holes don't pull galaxies in like vacuum cleaners. Instead, they sit at the center, stabilizing or sometimes disturbing the galaxy's shape through their enormous gravity. Stars orbit them like bees around an invisible flower, their motion revealing what we can't see. The one at the center of the Milky Way is called Sagittarius, a star. It's quiet now, but in the past, it may have shined with the light of countless swallowed stars. Some black holes are still active, blazing quasars seen from across the universe. Others, like ours, rest like sleeping giants, but their gravity never turns off. We might wonder, how did these giants form? Were they always there? Did they grow from smaller seeds? The truth is, we don't fully know, but gravity gives us clues. The way stars swirl around them, the jets of particles fired from their poles, the dance of matter caught near the edge of no return. In the quiet darkness of a black hole's gravity, there is mystery, but there is also order. The galaxy moves as one because of what lies at the center, even if that center makes no light, no sound, only pull. Gravity is the architect of everything. What is gravity, really? Is it a force, a curve in space, a story told by the universe? Perhaps it's all three, because when we trace every motion, every orbit, every structure we see in the sky, we find gravity behind it, not pushing, not shouting, just quietly shaping. From the tiniest dust grains in a planetary disk to the massive superclusters of galaxies far beyond our reach, gravity pulls without pause. It doesn't care if something is bright or invisible, heavy or light. It just connects things across time and space. Even time itself flows differently depending on gravity's strength. Near massive objects, time slows, light bends, and space stretches. Einstein didn't just describe this, he redefined it. Gravity became not a force pulling objects, but the shape of reality itself. And what's most humbling, we still don't fully understand it. There's more to gravity than what we've grasped. Something deeper, maybe tied to quantum fields, or the edge of dimensions we can't yet perceive. But even in our uncertainty, gravity keeps building. Planets, stars, us. So as we drift onward in this quiet journey, let the thought rest with you. Everything you see in the night sky is part of a design so ancient, so vast, and yet drawn together by something as soft as gravity. The invisible threads holding galaxies together. You can't see it when you look up, not with your eyes anyway. But something is holding those galaxies in place, something keeping them from flying apart, even though they're spinning like enormous pinwheels. That something is gravity. But not just any gravity. It's gravity doing what it does best, quietly shaping the dance without needing applause. Scientists noticed something strange when they looked at the way galaxies move. The stars on the outer edges weren't slowing down like they should have been. It was as if something extra was holding them together, keeping their motion in check. This strange observation led to a mystery that still isn't fully solved. If you take only the visible matter, the stars, gas, planets, There's just not enough mass to generate the gravitational pull we see. The edges of galaxies should fling off into space, but they don't. So where's the missing gravity coming from? That's where the concept of dark matter tiptoes in. It's called dark because we can't see it, not because it's scary. It doesn't emit light or absorb it. But we know it's there, like the wind you can't see but feel when it moves the trees. Without dark matter, our entire model of galactic structure falls apart. It acts like scaffolding, holding galaxies in their elegant shapes, threading invisible filaments across the cosmos. These filaments are not random. They guide the very architecture of the universe. Clusters of galaxies gather along them as if following the quiet rivers of gravity. And yet, no one knows exactly what dark matter is. Is it a new kind of particle? A relic from the Big Bang? Or is gravity itself playing tricks on us? Questions swirl where silence reigns. There's something haunting about how galaxies stay together, not with chaos, but with balance. Billions of stars, each with their own path, held in formation across billions of years. No conductor, no strings, just the invisible hand of gravity, brushing lightly against everything. Even though we don't fully understand dark matter, its gravitational fingerprint is undeniable. It's the silent glue that binds the stars, the whisper that says, "Stay close, don't drift too far." So when you look at those stunning spiral arms in a galaxy photo, remember, they are only part of the picture. They're dancing in formations they can't explain themselves, held by something unseen, unknown, but incredibly real. And out there, in that vast emptiness between stars, it is gravity that never lets go. When gravity creates giant walls of nothing, most people picture the universe as full of stars, but the truth is, it's mostly empty. That emptiness, however, isn't random. It has shape. It has boundaries. Cosmic voids, enormous regions with very few galaxies, stretch across space like quiet bubbles. But these voids aren't dead zones. They are shaped, sculpted, even, by gravity. It pushes matter together in some places and leaves absence in others. And what's left behind is this eerie balance between being and not being. Imagine pouring syrup across a plate. It doesn't spread evenly. It pools, it streaks, it clumps into threads. That's what gravity does with matter on a cosmic scale. Galaxies aren't scattered like sprinkles. They're drawn into vast filaments and nodes with voids in between. These voids aren't just blank space. They're the canvas on which structure appears. Without them, there would be no contrast, no definition, no skeleton for the universe to grow on. As we map the cosmos, we see patterns emerge, web-like structures spanning hundreds of millions of light years. These aren't just poetic ideas, they're real. Gravity doesn't just clump matter together, it creates emptiness too. That emptiness is necessary. Just like silence makes music possible, voids make the cosmic structure visible. Without the absence, the presence wouldn't stand out at all. Even in these dark, lonely voids, gravity whispers. It's not gone, it's just gentler here. The few galaxies that do exist in these voids often behave differently. Their evolution is slower, their interactions more rare. It's as if gravity takes a breath in these regions, a pause between movements, a softer pulse. So the next time you imagine space, don't just picture the stars. Picture the spaces between them, the silent gaps, the gentle hollows. Because in the architecture of the universe, even nothingness is shaped by gravity's hands. Gravity's role in cosmic echoes, long before galaxies were born, there were ripples, not in water, but in space itself. Left over from the Big Bang, these primordial sound waves stretched across the newborn universe. And gravity, it played the role of sculptor and conductor. These echoes, called baryon acoustic oscillations, are imprinted in the distribution of galaxies today. You can still see their soft traces in the way matter clusters. Gravity froze them into place, like fossilized chords from a song we can no longer hear. These ripples weren't sound as we know it, not through air, but pressure waves moving through hot plasma. Gravity pulled, the expanding universe pushed, and in that tension, waves formed. Some regions became denser, others more hollow. Over time, those slight differences turned into galaxies and clusters and voids. Gravity gave those waves permanence. It remembered the song even when the instruments stopped playing. What's strange is that these echoes are still detectable. When scientists chart the distances between galaxies, they find repeating patterns, like the fingerprints of early gravity. It's almost romantic in a way, gravity leaving behind cosmic rhythms, not just forming things but preserving their harmony. The universe doesn't forget its first breath, and gravity is its memory. And here's the quiet miracle. Those ripples, those oscillations, are now one of our best tools for understanding the universe's shape and history. They help us measure cosmic expansion. They help us map the invisible scaffolding that underpins the galaxies. It's gravity's echo that gives us a ruler to trace the universe's journey. So in the quiet darkness between stars, there is still music, faint, ancient, and invisible. Gravity didn't just mold the matter, it wrote the rhythm. And somewhere, in the way galaxies drift, that rhythm still lingers. The gentle grip of Lagrange points. Gravity isn't always pulling us down. Sometimes it creates balance, stillness, even safe harbors in the chaos of space. Lagrange points are one of those quiet gifts. They're special positions where the gravitational forces of two large bodies, like the Earth and the Sun, balance the motion of a smaller object. And when something rests there, it stays. Not by force, but by gentle alignment. It's like finding the eye of a storm and taking a breath. There are 5 such points between Earth and Sun. Satellites like the James Webb Space Telescope sit in these stable pockets, gently held by the balancing act of gravity. They don't need to burn much fuel. They don't fight the pull. They ride it, resting in the curve of the universe. These points are not mystical. They are mathematical, but they feel almost poetic, like cosmic cradles. What makes Lagrange points so fascinating is their fragility. Just a little push and you drift. But if you stay centered, you remain. That balance is hard to find, even harder to maintain. But once you're there, gravity sings a soft lullaby, a song of stillness, not motion. And in a universe that rarely stops moving, that's a kind of miracle. Astronomers dream of using these points to build observatories, space stations, even future outposts. Not because they're convenient, but because they're peaceful. Gravity, when balanced, becomes a partner, not a prison. It lets us stay without struggle. So the next time you look up and imagine floating in space, know that there are places, few but real, where the universe holds you not with force, but with grace. Black holes, gravity's silent extremes. Everything we've explored so far has shown gravity as gentle, patient, steady. But there's another face to it, a face that doesn't smile. Black holes are where gravity stops being subtle. These are not just dense objects. They're points in space where gravity has curled in on itself so tightly that not even light can escape. But even here, in this extreme, gravity doesn't scream. It just waits, quietly. Black holes form when stars collapse under their own weight. Gravity pulls inward, and with no force to resist, the matter folds tighter and tighter until a singularity forms. But what's strange is how quietly black holes exist. They don't shine. They don't announce themselves. You only see their presence by what they erase. Their pull is absolute, but it's not chaotic. It's tidy, predictable, a perfect trap with invisible walls. And yet, they are some of the most beautiful things we've ever imaged. Glowing accretion disks swirling around nothingness, light spiraling in, motion frozen at the edge. Some scientists believe black holes may hold secrets about the universe's deepest rules: quantum gravity, time, information itself. These are not just objects, they are questions, wrapped in darkness. Gravity, when pushed to its quietest extreme, becomes mystery itself. So yes, gravity can be soft, it can be patient, but at its most intense, it becomes silence so complete, it bends reality. And yet, even in that silence, there is wonder, and gravity's grip never loosens. When gravity sleeps inside a black hole, there's a place in the universe where gravity stops pulling and starts swallowing. We call it a black hole, but the truth is far stranger than the name suggests. Inside this abyss, gravity folds so tightly it wraps space and time into knots. The pull isn't just downward, it's inward, through dimensions we can't even picture. In this place, silence is not the absence of sound, it's the collapse of structure itself. And if gravity sleeps anywhere, it's here, quietly warping everything around it without a sound. We often imagine black holes as monsters, loud, dangerous, devouring stars in bright flashes of light. But in truth, most of them are silent sleepers, curled in the fabric of the cosmos, unnoticed until something stumbles too close. Their power doesn't scream, it whispers, steadily reshaping the space around them like a deep breath held for millions of years. Time near them stretches so far it almost stops, like a still pond refusing to ripple. If you fell toward one, you wouldn't feel a pull. There's no hand yanking you down. You'd just notice the stars behind you bending strangely, like you were swimming through a thick lens. And then everything would stretch, not because your body is changing, but because space around you is. It's not the fall that's strange, it's the stillness during it. Inside the event horizon, the point of no return, gravity no longer lets anything go. Not light, not sound, not memory. You could scream forever and no one would ever hear it. Not because the sound is swallowed, but because the very laws that carry sound break down. In this silence, gravity becomes something beyond our understanding. Not a force, but a directionless current, turning reality inward. Even black holes are not permanent. Over billions of years, they leak their own gravity away through something called Hawking radiation, a gentle loss, particle by particle. Imagine gravity unwinding itself, pixel by pixel, until even the black hole fades into cold dust. It's one of the quietest exits in the universe. No bang, no collapse. Just an ending so still, only time remembers it. The slow war dance of galaxies. Galaxies do not just spin, they drift, twist, and gently crash into each other like dancers in a slow cosmic waltz. The rhythm is set not by the stars, but by gravity moving in the background like music no one hears. For millions of years they circle each other, pulled closer by invisible strings. And when they meet, there is no explosion, only reshaping. The Milky Way is not still. Right now, it's drifting toward another giant, the Andromeda Galaxy. But they won't collide the way cars do. Their stars are so far apart that most of them won't even touch. Gravity doesn't crash things together. It weaves them into new shapes, like a slow-motion sculpture garden drifting through space. As galaxies merge, their black holes often spiral toward each other at the center, pulled tighter and tighter by gravity. And when they finally meet, they don't just combine, they ripple. A wave of gravity spreads through space itself, like a soft drumbeat traveling through nothingness. These gravitational waves pass through Earth even now, and we barely notice them. Inside these merged galaxies, new stars are often born. Clouds of gas stirred by gravity begin to collapse inward, forming glowing nurseries. So from the silence of one union comes a burst of light. It's a quiet paradox, the death of two galaxies giving birth to thousands of suns. And then, after all the motion, everything slows again. The new galaxy finds its shape, calms its spin, and joins the great web of the cosmos, held not by walls or edges, but by gravity's quiet grip. Gravity's gentle grip on light. We often think of light as free, unbound, racing across the universe at the fastest speed possible. But even light feels gravity's touch. When it passes a massive object, it bends slightly, just enough to be seen if you're looking carefully. It's called gravitational lensing, and it's one of the softest, strangest things gravity does. Imagine seeing a star behind a galaxy. It should be hidden, but its light curves around, bent by the galaxy's mass, reaching your eye as if nothing stood in the way. Gravity, in this case, acts like a lens, but not made of glass, made of space itself. Sometimes distant galaxies appear stretched and doubled in the sky, their light twisted into arcs and halos. This isn't a trick, it's gravity playing with time and vision. You're not just seeing light bent, you're seeing a glimpse of where that light has been and where it could have gone. In this way, gravity allows us to peer deeper into the universe than we ever should. It's like nature giving us an extra tool, a magnifying glass made of mass, curving photons with gentle precision. These small bends in light tell us stories we couldn't otherwise hear. And perhaps the most haunting part is this. The light we see now, lensed and bent and doubled, may come from galaxies long gone, collapsed, changed, or faded. Gravity lets us see their ghostly images echoing across space, long after their fires have dimmed. The hidden web that holds the universe. We often picture the universe as scattered stars and floating galaxies, but underneath it all, there's a structure we can't see. A cosmic web, made not of thread but of gravity. A network so vast it connects everything, not with ropes or walls, but with pull. Galaxies do not float randomly. They follow invisible paths shaped by ancient forces, drawn into filaments, clustered like beads on a string. These threads are dark matter's doing, and gravity is what pulls the strings. Even in darkness, patterns emerge. Some regions of space are nearly empty, vast voids where galaxies are rare. Others are dense crossroads where many threads of this web intersect. Gravity shapes it all, not quickly, but patiently, like a spider spinning for billions of years. When we map the universe using radio waves, X-rays, and deep-field images, we start to see this web more clearly. It looks almost biological, like neural networks or blood vessels. As above, so below. Gravity repeats itself in forms we instinctively recognize. And though we may never touch these strands, we feel them. They guide galaxy formation, influence cosmic expansion, and shape the journey of light itself. Gravity does not just hold things down, it holds everything together. Where gravity goes, time follows. Time and gravity are deeply connected, not just in science, but in feeling. You've probably noticed how time seems to slow in waiting rooms, or race forward when you're in love. In space, it's not just emotion, it's physics. Where gravity is strong, time moves slower. Where gravity is weak, time flows more freely. This isn't just theory. Astronauts who spend time in orbit experience slightly different clocks than we do, not just because they're moving fast, but because they're farther from Earth's centre of gravity. Even a few microseconds count. Now picture a neutron star, the collapsed core of a giant sun. Its gravity is so intense that time near its surface crawls compared to far away. If you could sit on its edge, a minute might pass while hours fly elsewhere. It's as if gravity holds not just matter, but time itself. This relationship becomes even stranger near black holes. From a distance, someone falling in appears frozen, stuck just outside the event horizon. But from their perspective, time flows normally. It's the rest of the universe that speeds away, leaving them behind. Gravity doesn't just shape space, it pulls on time too, stretching, slowing, and twisting it into paths that make memory and future swirl together like currents in a dark sea. When space-time curves around nothingness, most people imagine gravity as something that pulls, a force dragging objects toward each other. But in deep space, gravity reveals its true nature. It isn't pulling at all, it's bending. Imagine a blanket being gently pressed in the middle. Objects don't fall, they follow curves in fabric they cannot see. The deeper the curve, the more tightly reality clings. This isn't some fancy metaphor. It's what Einstein discovered. Gravity is the warping of space and time itself. In space, you don't go towards something, you simply fall along the path carved by invisible curves. Near a star, these curves are gentle, like waves in a slow ocean. But near a black hole, the blanket folds like a deep whirlpool, and everything nearby spirals inward, not because it's being pulled, but because straight lines are no longer straight. There is no path around it anymore. Even light, the fastest traveller we know, finds itself swept along these invisible curves. This warping doesn't just shape travel, it alters the very definition of direction. Up and down lose meaning. Left and right drift away into the stars. And this is where the silence deepens. There's no sound as time slows near these curves, no flashing alert that reality has bent. You could pass right through a warped space-time field and never realize, until your clock ticks slower than your twins, or your path takes you somewhere unexpected. In the great halls of the cosmos, gravity is the quiet architect, never loud, never boastful, but it's always there, changing the very rules of space and time with its hush. This bending explains why planets orbit in ellipses, why moons circle their hosts, and why galaxies hold their shape. Not because something is pushing them or pulling strings, but because the universe has laid out tracks. And those tracks are bent. Gravity doesn't command, it invites, it sculpts. It holds you in place by gently changing the shape of where forward leads. And maybe that's the strangest part of all. Gravity is not a thing you can touch. It's not an object. It's an instruction hidden in the language of geometry. Wherever there is mass, there is story. And gravity is how that story gets told, silently, across billions of years. The dance of orbits is a whisper from gravity. Out in space, orbits look like action, fast spins, spirals, loops. But if you listen quietly, they're just gravity whispering a rhythm. Planets don't run in circles out of effort. They glide. They surrender. Every orbit is a silent agreement between motion and mass. One says, "I will keep moving." The other replies, "I will keep curving the path." Together they dance endlessly, never colliding, never tiring. It's easy to forget just how delicate this balance is. Move a little faster and you escape the orbit. Move too slowly and you fall inward. Most celestial objects have found their perfect balance, not by design, but by trial and collapse over billions of years. Moons that failed the rhythm fell to their planets. Asteroids that missed their mark either drifted into the sun or were flung into icy exile. What remains today is the success story of gravity's gentlest dancers. Even our moon, which tugs at Earth's tides, is slowly drifting away. An inch here, a centimetre there. Over millions of years, even this quiet departure reshapes our days and nights. Orbits are not permanent. They shift. They evolve. The music of gravity is always playing, but sometimes the beat changes ever so slightly. Gravity's dance is also a clock. The orbit of a planet around its star defines its year. The spin of a moon around a planet sets its month. Even galaxies spiral in slow motion, their stars bound in vast orbits that take hundreds of millions of years. These motions become calendars written into the stars. When you look up, you're reading a cosmic schedule kept flawlessly by gravity. And all this movement, all this rhythm happens without a single sound, without wires, without engines, just curves, just mass, just motion. It's the most graceful choreography in existence, and it's still going. Gravity doesn't just hold us, it gathers time. There's something odd about how gravity touches time. It doesn't just stretch it or slow it, it gathers it. If you could stand on the surface of a white dwarf, a star packed into a city-sized sphere, time would tick slower for you than for your friend floating in orbit. It's not imagination, it's measurement. The deeper the gravity well, the thicker the syrup of time becomes. It's hard to feel this on Earth, but it's there. A person living at sea level actually experiences time a fraction of a second slower each year than someone living on a mountain peak. Tiny effects, sure, but they're real. The GPS satellites circling above us have to account for this difference constantly. Without adjusting for gravity's impact on time, your location on your phone would drift miles off course every day. So gravity doesn't just shape space, it pulls on time too. It holds time close. Near a black hole, this effect becomes dramatic. Time slows. Dramatically. To an outside observer, someone falling toward a black hole never quite crosses the event horizon. They freeze in place. But from the falling person's view, time feels normal until it doesn't. Until it begins folding back in on itself in ways we barely understand. Imagine this. Light from distant stars rushing past you, stretching into deep reds, time slowing with every heartbeat, the feeling of falling without ever hitting anything solid. That's what gravity can do to time when it's deep enough. It's not just motion it commands, it's memory, decay, perception, time itself. And yet all of it happens in silence. No alarms, no friction, no drama. Gravity changes time with the grace of a breath held too long, and that breath is still being held right now, all across the universe. Light is gravity's most obedient student. We often think of light as untouchable, the fastest, freest thing there is. But even light bends its path around gravity. It follows the rules. When Einstein predicted this in 1915, many doubted it. But in 1919, during a solar eclipse, light from distant stars was seen bending around the sun, just as he said it would. It was a moment when the universe revealed its blueprint to us. This bending of light, called gravitational lensing, allows us to see galaxies hidden behind others. The light curves around massive objects, creating rings, arcs, and duplicates of distant worlds. Some even call it nature's telescope. It lets us see farther, not because our eyes got better, but because gravity stepped in to guide the light. Think of that for a second. Gravity, without any mind or hand, has become a tool of vision, a way to glimpse things we shouldn't be able to see. In the deep silence of space, the biggest masses are quietly magnifying the faintest lights. It also means that what we see isn't always where it truly is. A star might appear to shine from one direction when it's actually far off to the side, its light curved across space. Reality is distorted, gently, almost like looking through rippling water. And yet, this is not a trick. It's truth, told in a different language. Gravity doesn't force light to stop. It simply nudges its direction. It lets light pass, but on a path that curves like a whisper following a tunnel. It's poetic in a way, the most silent force guiding the brightest messenger. The quiet sculptors of galaxy clusters. In the largest structures we know, clusters of galaxies, gravity is the invisible hand shaping everything. One galaxy may have billions of stars, but when hundreds of galaxies are bound together, drifting through deep space, gravity becomes something else entirely, a weaver of cosmic tapestries. These galaxy clusters aren't chaotic. They form filaments and webs, long strands of matter bound by gravity's whisper. Even between the galaxies, there's dark matter, adding to the pull. And while we can't see that dark matter directly, we know it's there because of the way galaxies move and the way light bends. Within these clusters, galaxies sometimes collide, but not like cars. They pass through each other, their stars rarely touching, but their gases crash, their motions change, and gravity reshapes their paths. It's like watching silent oceans of light ripple across billions of years. It's here, in these quiet collisions, that new stars are born. Gas clouds are stirred. Black holes feed. The universe renews itself again and again under gravity's silent guidance. Without force, without noise, just motion and time. As we move ahead, gravity's role becomes more mysterious and more personal. What if this silent sculptor is also shaping things much closer to home,